A fire hydrant, also called fire plug, is a connection point by which firefighters can tap into a water supply. It is a component of active fire protection. Operation: Clapper valve, a New York City hydrant hooked to an FDNY fire engine with a turgid hose actively pumping water. The user attaches a hose to the fire hydrant, then opens a valve on the hydrant to provide a powerful flow of water, on the order of 350 kilopascals, 50 lbf/inch squared. This pressure varies according to region and depends on various factors including the size and location of the attached water main. This user can attach this hose to a fire engine, which can use a powerful pump to boost the water pressure and possibly split it into multiple streams. One may connect the hose with a threaded connection, instantaneous quick connector, or a storage connector. A user should take care not to open or close a fire hydrant too quickly, as this can cause a water hammer, which can damage nearby pipes and equipment. The water inside a charged hose line causes it to be very heavy, and high water pressure causes it to be stiff and unable to make a tight turn while pressurized. When a fire hydrant is unobstructed, this is not a problem, as there is enough room to adequately position the hose. Most fire hydrant valves are not designed to throttle the water flow, they are designed to be operated full on or full off. The valving arrangement of most dry barrel hydrants is for the drain valve to be open at anything other than full operation. Usage at partial opening can consequently result in considerable flow directly into the soil surrounding the hydrant, which, over time, can cause severe scouring. Gate or butterfly valves can be installed directly onto the hydrant orifices to control individual outputs and allow for changing equipment connections without turning off the flow to other orifices. These valves can be up to 12 inches in diameter to accommodate the large central steamer orifices on many U.S. hydrants. It is good practice to install valves on all orifices before using a hydrant, as the protective caps are unreliable and can cause major injury if they fail. When a firefighter is operating a hydrant, he or she typically wears appropriate personal protective equipment, such as gloves and helmets with face shield worn. High-pressure water coursing through a potentially aging and corroding hydrant could cause a failure, injuring the firefighter operating the hydrant or bystanders. In most jurisdictions, it is illegal to park a car within a certain distance of a fire hydrant. In North America, the distances are commonly 3 to 5 meters or 10 to 15 feet, often indicated by yellow or red paint on the curb. The rationale behind these laws is that hydrants need to be visible and accessible in an emergency. Other uses: children playing in the spray of a fire hydrant in Philadelphia, Pennsylvania. A reduced pressure zone device is used to prevent backflow when supplying water to a construction site to prevent casual use or misuse. The hydrant requires special tools to be opened, usually a large wrench with a pentagonal socket. Vandals sometimes cause monetary loss by wasting water when they open hydrants. Such vandalism can also reduce municipal water pressure and impair firefighters' efforts to extinguish fires. Sometimes those simply seeking to play in the water remove the caps and open the valve, providing residents a place to play and cool off in summer. However, this is usually discouraged as residents have been struck by passing automobiles while playing in the street in the water spray. In spite of this, some U.S. communities provide low-flow sprinkler heads to enable residents to use the hydrants to cool off during hot weather, while gaining some control on water usage. Most fire hydrants in Australia are protected by a silver-colored cover with a red top, secured to the ground with bolts to protect the hydrant from vandalism and unauthorized use. The cover must be removed before use. In most areas of the United States, contractors who need temporary water may purchase permits to use hydrants. The permit will generally require a hydrant meter, a gate valve and sometimes a clapper valve, if not designed into the hydrant already, to prevent backflow into the hydrant. Additionally, residents who wish to use the hydrant to fill their in-ground swimming pool are commonly permitted to do so, provided they pay for the water and agree to allow firefighters to draft from their pool in the case of an emergency. Municipal services, such as street sweepers and tank trucks, may also be allowed to use hydrants to fill their water tanks. Often sewer maintenance trucks need water to flush out sewerage lines, and fill their tanks on site from a hydrant. If necessary, the municipal workers will record the amount of water they used, or use a meter. Since fire hydrants are one of the most accessible parts of a water distribution system, they are often used for attaching pressure gauges or loggers or monitor system water pressure. Automatic flushing devices are often attached to hydrants to maintain chlorination levels in areas of low usage. Hydrants are also used as an easy above-ground access point by leak detection devices to locate leaks from the sound they make. Fire hydrants may be used to supply water to ride control vehicles. These vehicles use a high-pressure water cannon to discourage riding. Construction, hydrant installation in Ontario, Canada. In areas subject to freezing temperatures, only a portion of the hydrant is above ground. The valve is located below the frost line and connected by a riser to the above ground portion. A valve rod extends from the valve up through a seal at the top of the hydrant, where it can be operated with the proper wrench. This design is known as a dry barrel hydrant, in that the barrel, or vertical body of the hydrant, is normally dry. A drain valve underground opens when the water valve is completely closed. This allows all water to drain from the hydrant body to prevent the hydrant from freezing. In warm areas, hydrants are used with one or more valves in the above ground portion. Unlike with cold weather hydrants, it is possible to turn the water supply on and off to each port. This style is known as a wet barrel hydrant. Both wet and dry barrel hydrants typically have multiple outlets. Wet barrel hydrant outlets are typically individually controlled, while a single stem operates all the outlets of a dry barrel hydrant simultaneously. Thus, wet barrel hydrants allow single outlets to be opened, requiring somewhat more effort, but simultaneously allowing more flexibility. A typical U.S. dry barrel hydrant has two smaller outlets and one larger outlet. The smaller outlet is often a store's connection if the local fire department has standardized on hose using store's fittings for large diameter supply line. The larger outlet is known as a steamer connection, because they were once used to supply steam-powered water pumps, and a hydrant with such an outlet may be called a steamer hydrant, although this usage is becoming archaic. Likewise, an older hydrant without a steamer connection may be called a village hydrant. Appearance hydrant coloring may be due to either purely practical criteria or more artistic. In the United States, the AWA and NFPA recommend hydrants be colored chrome yellow for rapid identification apart from the bonnet and nozzle caps, which should be coated according to their available flow. Class AA hydrants, greater than 1,500 GPM, should have their nozzle caps and bonnet colored light blue, Class A hydrants, 1000 to 1499 GPM, green. Class B hydrants, 500 to 999 GPM, orange. Class C hydrants, 0 to 499 GPM, red and inoperable or end of system, risking water hammer, black. This aids arriving firefighters in determining how much water is available and whether to call for additional resources, or find another hydrant. Other coatings can be and frequently are used, some of greater complexity, incorporating pressure information, others more simplistic. In Ottawa, Ontario, Hydrant Colors communicate different messages to firefighters. For example, if the inside of the hydrant is corroded so much that the interior diameter is too narrow for good pressure, it will be painted in a specific scheme to indicate to firefighters to move on to the next one. In many localities, a white or purple top indicates that the hydrant provides non-potable water. Where artistic and or aesthetic considerations are paramount, hydrants can be extremely varied, or more subdued. In both instances this is usually at the cost of reduced practicality. In Germany, most hydrants are located below ground, underfloor hydrant, and are reached by a stand drawer, riser, which provides the connections for the hoses. In the United Kingdom and Ireland, hydrants are located in the ground. Yellow H hydrant signs indicate the location of the hydrants, and are similar to the blue signs in Finland. Mounted on a small post or nearby wall etc., the two numbers indicate the diameter of the water main, top number, and the distance from the sign, lower number. Modern signs show these measurements in millimeters and meters, whereas older signs use inches and feet. Because the orders of magnitude are so different, 6 inches versus 150 millimeters, there is no ambiguity whichever measuring system is used. In areas of the United States without winter snow cover, blue reflectors embedded in the street are used to allow rapid identification of hydrants at night. In areas with snow cover, tall signs or flags are used so that hydrants can be found even if covered with snow. In rural areas tall narrow posts painted with visible colors such as red are attached to the hydrants to allow them to be found during heavy snowfall periods. The tops of the fire hydrants indicate the amount of pressure each one will put out. This is good because it makes the choice of what hydrants will be used to supply water to the fire scene. Blue 1500 GPM or more very good flows, green 1000 to 1499 GPM good for residential areas, orange 500-999 GPM marginally adequate, red below 500 GPM inadequate. The hydrant bodies are also color-coded: white public system hydrant, MUD, yellow private system hydrant connected to public water main, red special operation hydrant not used except for special procedures, violet non-potable supply effluent, pond or lake supply,